A 4-mark question asked from application of derivatives. An open tank with a square base and a vertical sides is to be constructed from a metal sheet so as to hold a given quantity of water. Show that the cost of the material will be least when the depth of the tank is half of its width. If the cost is to be borne by nearby settled lower income families for whom water will be provided, what kind of value is hidden in this question? So let us first assume side of the square base be x and depth of the tank be y. Then the volume of the tank will be x square into y, or y is equal to the volume by x square, right? So, but the volume V is constant. This is the volume of the water which is fixed. So the cost of material has to be least when the area of the sheet used is minimum, right? The cost of material is least when the area of the sheet is minimum. So we have to find the minimum area now, right? So surface area of the tank, how to find the surface area of a tank now? So sheet will be used to make the surface, right? So surface area of the tank is given by the base area plus 4 times the walls area x into y, which is again in terms of x1 if we have to write, we can convert that as 4v by x. So this is the area and we have to minimize this area. So rate of change of area with respect to the side length dA by dx is given by 2x minus 4v by x square. So and it has to be 0 so that we get the minimum area. So when you do this, when you equate this, we get x cube is equal to 2v. Therefore, the given function will now change to v by x square, right? So we are going to substitute x cube is equal to v. So what we get is y will be equal to x cube by 2x square, which will become x by 2. So again, differentiating with respect to x, again, second order derivative, we get 2 plus 8v by x cube. That is from here, we are differentiating again with respect to x, which has to be greater than 0. Therefore, it is always greater than 0 because x is positive. That means we can say the area is minimum, thus the cost is minimum. The cost has to be minimum means area has to be minimum, right? Is minimum when the height y is equal to what? X by 2. It's a 4-mark question, so we need to understand the connection properly. So by using the volume in terms of y is equal to v by x squared, we get 1 mark. And finding the surface area properly, we get 1 mark. So differentiating this will give you 0.5 marks. And writing x cube in terms of v will give you 0.5 marks. And proving this will give you 0.5 marks. And this statement will give you another 0.5 marks. So that is how you get totally 4 marks for this question.